You know that feeling when you need to get a solid handle on something important, like yesterday?
Yeah.
Especially with aviation, digging through all the regulations and paperwork. It can feel like a huge task.
It really can.
Well, that's exactly why you're here. Welcome to the Deep Dive. This time, we're zeroing in on the crucial regulations, the forms, the records, and publications that are basically the foundation for keeping aircraft airworthy.
And we've got a great resource to help us, well, cut through the noise. It's excerpts from a chapter called Regulations, Maintenance Forms, Records, and Publications.
Okay.
Our mission today is pretty straightforward. Pull out the really important, interesting bits of these rules, give you a clear picture without, drowning you in details.
Sounds good. Let's get into it, Ben. When we talk FAA regulations, the big picture is Title 14 of the Code of Federal Regulations, or 14 CFR.
Right.
And it's hefty, 5 volumes, believe it or not.
Yeah, it's a lot.
And what's interesting is the first 3 volumes, they've got like 75 active regulations, and they're all about the FAA itself.
Uh-huh. The other 2 cover different things: aviation proceedings, space travel, even NASA stuff.
So within these FAA regs, we can kind of see 3 main categories emerging, can't we?
Yeah, exactly. There's administrative, airworthiness certification, and airworthiness operation.
Okay, so like how the FAA is run, how planes get approved in the first place, and then how they're kept safe while flying.
That's a great way to think about it, like managing the building, certifying it safe, and then the rules for using it. Understanding this structure really helps clarify how airworthiness is governed, from the big picture down to the specifics.
Got it. Now, I've definitely heard the term FARs, FARs thrown around, Federal Aviation Regulations.
Right, that was the common term going way back to 58.
But there's a catch, isn't there? Another set of FARs.
Uh-huh. Title 48, the Federal Acquisitions Regulations. Same acronym.
Okay. That would be confusing.
Yeah, it caused some mix-up. So the FAA started pushing towards using 14 CFR Part XX to be really specific.
Makes sense. And you mentioned something about odd numbers.
Oh yeah, a little bit of trivia. Most of the regulations and their sections are odd numbered. Apparently, back in 58, they did that deliberately to leave space.
Space for what?
To add new rules later without having to renumber everything that already existed. Pretty clever, actually.
Huh. Forward thinking. Okay, what about situations that are kind of unique or temporary?
That's where Special Federal Aviation Regulations, or SFRs, come in. Think of them as temporary rule changes for specific situations, usually with a limited time frame.
So they're like little patches or adjustments.
Kind of. And it's important to know their numbering is just sequential. SFR 102, for example, doesn't link numerically to any specific CFR part.
It was just the 100th-ish one they issued.
Pretty much. And that SFR 102 is actually a good example. It offered some temporary relief for U.S. military and civilian folks serving overseas supporting the armed forces.
Okay. So really specific and time-limited.
Exactly. It shows how targeted they can be.
So for our deep dive today, we're really focusing on the regs about airworthiness certification.
Yep. That's the plan. And there are about 30 of them.
Wow, 30. That alone tells you how much goes into making sure a plane is safe to fly.
It really does. And at the very heart of all this is the definition of airworthy.
Which isn't just a casual term. It has a very specific legal meaning.
Absolutely. And it's actually, relatively recent that the FAA formally defined it in 14 CFR Part 3, Section 3.5.
Okay, so what's the official definition?
Airworthy means the aircraft conforms to its type design and is in a condition for safe operation.
Conforms to type design and safe for operation. Seems simple, but I bet the devil's in the details.
You bet. Conforming to type design means it matches the approved blueprint, basically. And safe operation means nothing's broken or worn out that would make it unsafe.
Gotcha. Does Part 3 define anything else important?
It does. A product is defined as an aircraft engine, or a propeller.
Okay, the main components.
Right. And the definition of record is surprisingly broad. It covers pretty much any way information is kept: paper, electronic, even markings on the product.
So like a maintenance sticker on the panel could be a record?
Technically, yes. It's very encompassing.
Okay. And you mentioned airworthiness has 2 main phases.
Broadly speaking, yes. Original airworthiness, that's getting it certified from the factory.
Mm-hmm.
And recurrent airworthiness, that's everything you do to keep it airworthy throughout its life.
So the initial setup versus ongoing upkeep.
Exactly. And that original airworthiness piece, getting it certified initially, that's really where 14 CFR Part 21 shines.
Part 21, okay. And what are the other core regs?
The 3 big ones are Part 21 for certification, Part 43 for maintenance, and Part 91 for general operating rules.
21, 43, 91.
Got it. And you'll find many other airworthiness regs link back to those three pillars.
Makes sense. Before we dive into those parts, quickly, who at the FAA do maintenance techs usually deal with?
Primarily, they interact with the Flight Standards Service, or AFS.
The operational safety folks.
Right, the boots on the ground. And within AFS, it's usually the local Flight Standards District Office, the FSDO.
FSDO.
Though they might sometimes interact with the Aircraft Certification Service, AR, especially for big approvals or major changes.
Okay, good to know the players. Let's start digging into some specific maintenance-related regulations then. Where should we begin?
Let's start with the basics. 14 CFR Part 1 definitions and abbreviations.
The dictionary, basically.
Pretty much. It might not sound thrilling, but it's essential. A comprehensive list of terms pilots and mechanics both need to know.
Though sometimes specific parts have their own definitions too, right?
Correct. Part 1 isn't always exhaustive, and it also has abbreviations and symbols, but those are often more for flight ops.
Okay.
14 CFR Part 21 certification procedures for products and articles. This is the rulebook for getting type certificates, TCs, supplemental type certificates, STCs, production certificates, airworthiness certificates.
Import-export approvals.
Yeah.
The whole initial certification process.
Exactly. Its main focus is that original airworthiness, but it definitely impacts ongoing maintenance, too. While Section 21.50 is key, it covers instructions for continued airworthiness, the ICAs.
Ah, the maintenance manuals and instructions.
Right. When a new aircraft is built, it comes with these ICAs specifying all the required maintenance.
And what about for modifications, like an STC?
If the STC was developed after 1981, it must come with its own complete set of ICAs, too.
So the mechanic knows how to maintain the modified parts.
Precisely. And these ICAs have to cover 16 specific subjects laid out in the regs. They're really detailed.
Okay, vital stuff. Now, what about the standards the aircraft itself has to meet?
That brings us to the airworthiness standards, starting with 14 CFR Part 23. This covers normal, utility, acrobatic, and commuter category airplanes.
So most of general aviation, trainers up to small turboprops.
Generally, yes. The limits are usually 9 or fewer seats, though commuters can go up to 19 and a max takeoff weight of 12,500 pounds, or 19,000 for commuters.
And it details the design requirements.
Yep. 7 subparts covering flight characteristics, structure, design and construction, power plant, equipment, even the flight deck layout. It gets very specific CG limits, fastener strength, control design, everything.
Okay. Then the big planes.
That's 14 CFR Part 25 airworthiness standards, transport category airplanes. Think aircraft over 12,500 pounds max takeoff weight.
Airliners, cargo planes.
Commercial aviation.
Exactly. Though they don't have to carry passengers to be Part 25. It follows a similar structure to Part 23, just scaled up for larger, more complex aircraft.
And helicopters have their own parts.
They do. 14 CFR Part 27 is for normal category rotorcraft, smaller helos, 9 or fewer occupants, up to 7,000 pounds. Structure mirrors, Part 23.
And the bigger ones.
14 CFR Part 29 covers transport category rotorcraft over 7,000 pounds. It adds extra criteria based on seating, 9 or less versus 10 or more, and weight, a 20,000-pound threshold. Design subparts are similar again.
Makes sense. What about the engines and props? They need standards too. Absolutely. 14 CFR Part 33 covers aircraft engines, both piston and turbine, design, construction, and really demanding block tests they have to pass.
Block tests, like running them hard on a test stand.
Exactly, to prove they can handle the stress. And 14 CFR Part 35 does the same for propellers. Design, construction, tests, inspections, they need their own type certificates too.
Okay. Now, you mentioned something important earlier about which rules apply.
Ah, yes. Crucial point. An aircraft only has to meet the regulations that were in effect when it was built.
So an old plane doesn't need to meet today's newest design standards.
Correct. However, and this is a big however that does not apply to airworthiness directives, or ADs.
ADs are always mandatory, regardless of age.
Always. If an AD applies to your aircraft type, you have to comply.
Okay, let's talk about those ADs then. 14 CFR Part 39 airworthiness directives.
Right. So even with great design and testing, sometimes unsafe conditions pop up during operation.
Things break or wear out unexpectedly.
Exactly. If the FAA finds an unsafe condition that's likely to exist in other aircraft of the same design, they issue an AD.
And that forces owners to fix the problem.
Correct. The actual AD text isn't in Part 39 itself. It's published in the Federal Register as an amendment to Section 39.13. But Part 39 is the regulation authorizing them. They apply to aircraft, engines, props, even appliances.
Legally enforceable rules. Got it. Now, which regulation is really the mechanic's bread and butter?
That would be 14 CFR Part 43 maintenance, preventative maintenance, rebuilding, and alterations.
The core maintenance rulebook.
Absolutely. Its 13 rules and 6 appendices set the standards for maintaining basically all U.S. registered civilian aircraft. And it works hand in hand with Part 91 for continued airworthiness.
Okay, Part 43. We'll definitely need to dig into that one more. What about identifying aircraft and parts?
That's 14 CFR Part 45 identification and registration marking. It covers everything from the fireproof data plate on the aircraft.
With the serial number, manufacturer, model.
Right, to the specific FAA PMA markings required on approved replacement parts.
Parts manufacturer approval.
And of course, the big N number, the nationality and registration marks. Part 45 specifies the size requirements, which can vary based on age and type. It affects both original and ongoing airworthiness.
And actually registering the aircraft, getting that N number assigned.
That falls under 14 CFR Part 47 aircraft registration.
Okay.
Covers owner registration, dealer registration, the whole process.
Okay. What about certifying the people doing the maintenance?
That's primarily 14 CFR Part 65 certification, airmen other than flight crew members, while Part 61 is for pilots. Part 65 covers ATC operators, dispatchers, mechanics, repairmen, parachute riggers.
A whole range of non-flying roles.
Exactly. And our source mentions Chapter 15 goes into more detail specifically on mechanic certification.
We'll keep an eye out for that. And you mentioned SFRs again.
Just as another quick example, SFR 102, which we talked about, providing that relief for personnel serving overseas, reinforces how specific they can be.
Got it. Now, what about the operating rules, Part 91?
14 CFR Part 91 General Operating and Flight Rules. Yes, its main focus is flight operations, but it's very relevant for mechanics, too.
How so? Give me an example.
Well, Section 91.207 covers ELT battery replacement requirements. Section 91.213 deals with inoperative instruments and equipment, including minimum equipment lists, MELs.
Things a mechanic would definitely be involved with.
Absolutely. And crucially, Subpart E of Part 91 is dedicated entirely to maintenance, preventive maintenance, and alterations.
Ah, so a direct link back to maintenance standards.
Yes, it constantly refers back to Part 43 for the how-to.
Okay. Now things get more complex for air carriers and commercial operators.
They do. To understand those rules, we first need a quick look at 14 CFR Part 119 certification air carriers and commercial operators.
This sets the stage for Parts 121, 125, and 135.
Exactly. It determines which of those operating rules apply based on a few criteria.
Like?
Is it private carriage or common carriage? Is it for hire or not for hire? Is it a large or small aircraft using that 12,500-pound cutoff?
Okay, what's the difference between common and private carriage?
Common carriage is holding yourself out to the public, like a scheduled airline. Private carriage is usually carrying specific customers, often under longer-term contracts.
Got it. And Part 119 lists some operations that are exempt.
Yes, things like flight instructions, some sightseeing flights, agricultural operations, they don't fall under these specific carrier rules.
Okay, so Part 119 sets the framework. What about Part 121?
14 CFR Part 121 covers the big airlines operating requirements, domestic, flag, and supplemental operations, scheduled or unscheduled transport for hire.
Domestic, flag, supplemental. What defines those?
Schedule, where they fly, and aircraft type. Part 121 generally applies to turbojets, planes with 10-plus seats, or over 7,500-pound payload for domestic flag. Supplemental ops usually involve even larger aircraft.
And they need specific management roles.
Yes, Director of Safety, Director of Operations, Director of Maintenance, Chief Pilot, Chief Inspector, a whole required structure.
And for mechanics, which parts of 121 are most relevant?
Subparts J and L. They cover special airworthiness requirements and the operational manual details organization, inspection personnel, maintenance procedures, record systems.
And aging aircraft.
Yes, Section 121.1105 has specific aging aircraft inspection requirements.
Okay. What about Part 125?
14 CFR Part 125 is for certification and operations. Airplanes having a seating capacity of 20 or more passengers or a maximum payload capacity of 6,000 pounds or more, but used in private or non-common carriage.
So large aircraft, but not operating like a public airline.
Yeah.
Corporate flight departments, maybe?
That kind of thing, yes. They need operation specifications or op specs covering authorized operations, manuals, inspection programs, weight and balance, etc. Subpart E deals with their special airworthiness requirements.
And Part 135?
14 CFR Part 135 handles operating requirements, commuter and on-demand operations. Think shorter distance scheduled commuters and unscheduled on-demand, like air taxis or charters.
Okay, smaller commercial operations. Key requirements.
An operations manual is crucial, and Section 135.411 is big for maintenance. It differentiates requirements based on seating.
9 or less versus 10 or more.
Right. 9 or less generally follow manufacturer recommendations. 10 or more usually need their own FAA-approved maintenance manual written by the carrier.
Ah, a higher standard for larger passenger loads.
Generally, yes. There are other maintenance rules in 135.415-417 and 423-4433, and significantly, Section 135.422 added aging aircraft inspection rules for certain multi-engine scheduled ops with 9 or fewer seats involving detailed record reviews.
Wow, okay. Lots of layers depending on the operation.
Yeah.
What about the places where maintenance gets done? Repair stations?
That's 14 CFR Part 145 repair stations. It got a major rewrite in 2004.
Anything surprising in there?
Well, interestingly, you don't need an AMP certificate to work at a Part 145 repair station.
Really? So they can hire non-certificated people?
Yes, they can employ repairmen and non-certificated personnel. But the approval for return to service must be done by someone specifically authorized under Part 65, using the repair station's certificate number.
Ah, okay. The sign-off is still tightly controlled.
Exactly. They also need a detailed repair station manual covering organization, personnel, facilities, capabilities, training, record keeping, lots of stuff.
How long do they keep records?
Minimum of 2 years. And certificate validity differs for domestic versus foreign stations.
Okay. What about the schools that train mechanics?
That's 14 CFR Part 147 Aviation Maintenance Technician Schools. It sets the requirements for schools wanting FAA certification for airframe, power plant, or combined AMP training.
Minimum hours.
1,150 hours for A or P individually, 1,900 for combined AMP because of overlap in general subjects. The appendices detail the curriculum.
Got it. And finally, how does the FAA manage all this oversight with limited resources?
Through 14 CFR Part 183 representatives of the administrator. This covers the FAA's designee program, started way back in '62.
Using private sector experts.
Exactly. People authorized to act on the FAA's behalf due to budget and personnel limits. Think medical examiners, pilot examiners, DPEs, mechanic examiners, DMEs, engineering reps, DRRs, manufacturing inspection reps, DMRs, airworthiness reps, DRs.
So extending the FAA's reach through qualified individuals in the industry.
Precisely. Each has specific roles in certification and oversight.
Okay, that's a great overview of the regulatory landscape. Now let's really zoom in on those two key maintenance regs, Part 43 and Part 91.
Sounds good. Let's start with 14 CFR Part 43 Maintenance, Preventative Maintenance Rebuilding and Alteration.
Section 43.1, Applicability. Who does it apply to?
U.S. and foreign registered aircraft operating under Part 121 or 135 and their components.
Any tricky bits there?
The source highlights potential confusion with experimental aircraft. If a plane only ever had an experimental certificate, Part 43 doesn't apply to its maintenance.
But if it was standard category first, then put into experimental for maintenance.
Then Part 43 still applies. The original certification status matters.
Okay, important distinction. What about Section 43.2? Overhaul and rebuilding.
It defines these terms. Both involve full disassembly, cleaning, inspection, repair, reassembly, and testing.
What's the key difference?
The testing standards. Overhauled means tested to manufacturer's current approved standards and service limits. Rebuilt means tested to the tolerances and limits of a new item.
Rebuilt is essentially like new. Got it. Section 43.3, who can actually do the maintenance?
It lists 9 categories: certificated mechanics, repairmen, people working under their supervision, repair stations, air carriers, pilots with restrictions.
Pilots can do maintenance.
Yes, certain preventative maintenance, mainly. Also, helicopter pilots in remote areas under specific rules, some Part 135 pilots trained for specific cabin item removal installation, and manufacturers working on their own products.
Okay, quite a list. Now, Section 43.5, approving for return to service, the sign-off.
Critical step. Always needs a maintenance record entry per 43.9 or 43.11, and maybe FAA Form 337 for major actions.
Major actions. How do you know what's major versus minor?
That's crucial. Before starting work, you need to know, what am I doing? Is it a repair, fixing something, or alteration, changing something? Is it major or minor?
And major means?
Affects weight, balance, strength, performance, flight characteristics significantly, and isn't done using basic accepted practices. Minor is everything else. Part 1 and Appendix A help clarify.
And the data required is different too.
Yes. Minor actions need acceptable data, like manufacturer manuals or AC 43.13-1. Major actions need approved data, ADs, STCs, TCDS, DER approvals, FAA-approved service bulletins.
What if you need to do a major repair or alteration, but there's no pre-approved data?
That's where a field approval comes in. You fill out Form 337 explaining what you want to do and the data you propose to use, and submit it to the local FSDO.
And an FAA inspector reviews it.
Right. An Aviation Safety Inspector, ASI, might review it. If they approve the work and the data, they sign Block 3 on the Form 337.
Okay. Now, who can actually sign that approval for return to service? Section 43.7.
7 categories here. A certificated mechanic, a mechanic with inspection authorization, IA, a repair station, the manufacturer, an air carrier, a private pilot for preventive maintenance they did on their own plane, an LSA repairman, and a sport pilot, also for preventive maintenance.
What about a regular repairman without an LSA rating?
They can perform work within their rating, but cannot approve the aircraft for return to service. They just make a record entry of what they did.
Got it. Section 43.9, the maintenance record entry itself. What needs to be in it?
This excludes inspection entries, that's 43.1. For general maintenance, it's the what, when, who, description of work, completion date, and the signature, certificate number, and certificate type of the person approving return to service.
And if someone else did the work?
Their name needs to be included too. And remember, the signature only approves the work performed.
Right. And Form 337 for major repairs alterations.
Yes, unless it's a major repair done by a repair station, then they can use a signed work order or maintenance release instead.
Okay. Section 43.9, life-limited parts. This sounds important.
Very. It defines life-limited part and life status. It dictates how you handle parts that have a mandatory replacement time or cycle limit.
What are the requirements?
The person removing the part is responsible for controlling it and tracking its life limit using one of 7 methods: record keeping, tagging, non-permanent marking, permanent marking, segregation, mutilation, or another FAA-approved method.
And that life status info has to follow the part.
Absolutely. It must be transferred with the part. This rule is really about managing parts after they're removed.
Okay. Section 43.101, records for inspections. How is this different from 43.9?
Similar what, when, who requirements, type of inspection, date, and total time in service, signature certificate details of the person approving or disapproving return to service.
Disapproving, what happens then?
If an inspection finds issues making the aircraft unairworthy, the inspector disapproves it, gives the owner a list of discrepancies, and the log entry must reference that list.
Does the same inspector have to fix it or re-inspect it?
No. Any appropriately rated person or facility can fix the discrepancies. Then, a standard maintenance entry, per 43.9, is made approving the aircraft for return to service based on the corrective work done. No need to go back to the original inspector.
Interesting. So the disapproval just flags the problems.
Exactly. The entry format is slightly different for progressive inspections, too, and other program inspections need to identify the specific program.
Section 43.12, falsification. This seems straightforward but critical.
Absolutely critical. Honesty in records is paramount. Fraudulent entries are grounds for losing your certificate. The quote in the source says it all. Companies come and go, but my signature lasts a lifetime. I will not use it inappropriately.
Powerful. Section 43.13, performance rules, how you actually do the work.
Right. It says you must use manufacturer's manual SECA or other FAA acceptable methods like AC 43.13-1 and MANIS-2, especially for smaller, non-pressurized planes, unless 43.16 applies.
And use the right tools.
Yes. Proper tools, equipment, testing apparatus are required. You can use equivalent test gear if the FAA finds it acceptable, but proving equivalence is on you. Air carriers can use their approved manuals.
Okay. Section 43.15, more performance rules specifically for inspections.
Covers details for rotorcraft checks, annual 100-hour, must use a checklist covering Appendix D scope, check engine performance, and progressive inspections.
What are the key points for progressive inspections?
Must start with a full inspection, breaks big inspections into smaller tasks, defines routine versus detailed, requires IA oversight, needs an FAA-approved schedule, allows a 10-hour en route extension, intervals can change with experience, reverts to annual 100-hour if stopped.
Can inspections be done away from the main base?
Yes, by a rated mechanic, repair station, or manufacturer using the original program's procedures and forms.
Section 43.16, airworthiness limitations. Back to mandatory stuff.
Yes. Technicians must have and comply with the airworthiness limitations section found in Manufacturer Manual ISCAS, required by Part 21.50, or in OPS specs, Parts 1211135, or approved inspection programs, Part 91.409. These are mandatory replacement times or inspections, non-negotiable.
Got it. Must comply. Section 43.17, maintenance by Canadians.
Revised in 2005 due to the U.S.-Canada Safety Agreement. BASS, sets limits for Canadian AMEs and AMOs working on U.S.-registered aircraft in Canada.
Okay, now the appendices to Part 43. Appendix A.
Major alterations, major repairs, and preventive maintenance. It provides lists, though not exhaustive, broken down by airframe, power plant, prop, and appliance.
And it defines preventive maintenance.
Yes, simple tasks not involving complex assembly. And it clarifies that private pilots or hire can do these tasks on their own aircraft if it's not used in air carrier ops.
Appendix B. Recording major repairs alterations. Form 337 again.
Yes. Details how to fill out Form 337. Minimum 2 copies owner gets original. FAA in Oklahoma City gets a copy within 48 hours of RTS. Used to go to FSDO first, but that changed.
And the repair station exception.
Right. Part 145 stations can use a signed work order maintenance release instead of Form 337 for major repairs. Also, a third copy of 337 must be in the aircraft for ferry tanks in the cabin cargo area.
Appendix D. Scope of annual and 100-hour inspections.
The checklist items are identical for both. The difference is who can sign off IA needed for the annual. Requires cleaning the aircraft first. Says you have to inspect everything, even unlisted items. Then lists 8 specific areas for detailed checks. Fuselage, cabin, engine, gear, wing, empennage, prop, radio.
Appendix E. Altimeter system test. The 40101.
Required every 24 months for IFR flight in controlled airspace, per 91.411. Tests the static system, altimeter, and altitude reporting equipment. Results go in logs and on the altimeter.
Who can do it?
Manufacturer, appropriately rated repair station, or an airframe mechanic, but they can only do the static system test. Mechanics can't calibrate instruments that needs an instrument-rated repair station.
Good to know. And TSO'd items.
Considered tested at manufacturer.
Appendix F. ATC transponder test. The 413 test.
Also, every 24 months, per 91.413, and after installation or maintenance, test the whole system static system, per Appendix E, and the transponder itself. Specific tests like frequency, sensitivity, power output, mode S, requires log entries.
And who could do this one?
Manufacturer, rated repair station, or a Part 121135 operator with it in their continuous airworthiness program.
Okay, that covers Part 43 in detail. Now let's look at 14 CFR Part 91 General Operating and Flight Rules, focusing on the maintenance aspects in Subpart E.
Right. While Part 91 is mostly about flying the plane, Subpart A sets the stage. Section 91.7A says you can't operate an aircraft unless it's in an airworthy condition.
Back to that core definition. Conforms to type design and safe to operate.
Exactly. A pilot's pre-flight check mostly covers the safe operation part. Determining conformity often means checking the maintenance records.
So mechanics play a key role in helping owners meet that responsibility.
Definitely. Now, Subpart E maintenance, preventive maintenance, and alterations. Section 91.401 just clarifies that some parts of this subpart don't apply if you're operating under Parts 121, 125, 129, or 135 because they have their own, often stricter maintenance rules.
Okay, Section 91.403, General. Whose responsibility is airworthiness?
Primarily the owner or operator. They are responsible for maintaining the aircraft in an airworthy condition, including complying with all ADs.
Does the FAA notify owners about ADs?
Yes, they typically send ADs to the registered owner, and all maintenance must follow Part 43, manufacturers that LACA, and any mandatory items from OPS specs.
Section 91.405, maintenance required. What does the owner have to do?
Ensure required inspections get done, required repairs are made per Part 43, and proper log entries are made. Also, if something's inoperative, it needs to be repaired or placarded.
Section 91.407, operation after maintenance. Can you just fly it right away?
Only after it's been approved for return to service with a proper log entry. And if the maintenance could have affected flight characteristics, a rated pilot needs to do an operational flight check and log it.
Unless ground tests prove it's okay.
Right. If ground checks are sufficient to show no adverse effects, the flight check isn't needed.
Section 91.409, inspections. This is a big one. Annual inspection required.
Yes, within the preceding 12 calendar months, unless an exception applies.
Exceptions like?
Special flight permit, experimental light sport provisional certificates, aircraft under an approved Part 125135 program, progressive inspections, or certain turbine rotorcraft.
And 100-hour inspection.
Required if the aircraft is used for hire, including flight instruction for hire. There's that 10-hour allowance to get to an inspection facility.
And progressive inspections are an alternative.
Yes, an FAA-approved program that breaks the annual into smaller chunks to reduce downtime. Needs IA oversight, follows Appendix D scope, requires an FAA schedule.
Other options: continuous airworthiness programs, approved aircraft inspection programs, AAIP.
Yes, continuous programs are usually for Part 121135 operators. AAIPs are an option, mainly for Part 135. Owners can use the manufacturer's program or develop their own FAA-approved one. Time cycles carry over if you switch programs.
Okay. Sections 91.411 and 91.413, the 411 and 413 tests again.
Just reinforces the 24-month requirement and links back to Part 43 Appendices E and F for the procedures and who can perform them.
Section 91.415, changes to inspection programs. Can the FAA make you change your program?
Yes, if they deem it necessary for safety, the owner gets 30 days to contest it.
Section 91.417, maintenance records. You said this was fundamental.
Absolutely. It lays out what needs to be kept. 4 types of records mentioned.
Temporary and permanent.
Essentially, paragraph 1 covers temporary records maintenance, preventive maintenance, alterations, inspections. Kept for 1 year or until repeated superseded. Need description, date, signature, certificate info.
And B1 is similar.
Yes. B1 mirrors A1 regarding retention time. Paragraph A2 covers permanent records kept as long as you operate the aircraft and transfer it upon sale.
What's included in permanent records?
Total time, airframe, engine, prop, life-limited part status, time since overhaul for required items, current inspection status, current AD status, and Form 337s for major alterations.
What about the 411, 4443 tests and ferry tanks?
Those are covered too. 411443 test records kept 24 months. Form 337 for cabin cargo fuel tanks kept on board. All records must be available to FAA NTSB.
And your advice was don't keep logs in the plane.
Right. Too risky. Keep them safe. Maybe copies elsewhere.
Section 91.419, transfer of records. They go with the plane.
Yes, when sold. Can be plain language or coded. Purchaser can let seller keep physical records, but seller must still make them available to FAA NTSB if needed.
Section 91.421, rebuilt engine records. The zero-time concept.
Yes. If an engine is rebuilt by the manufacturer or an approved agency, it can get a new record showing no prior history. Must list rebuild date, ADs complied with, and manufacturer SBs incorporated during rebuild.
Okay, that clarifies the owner-operator responsibilities under Part 91. Now, briefly, what about the older rules, the FARs?
Civil Air Regulations, CRs. Pre-1958 rules, essentially. Before 1926, it was the Wild West. The Air Commerce Act of 26 started federal oversight, leading to the CAA and CARs.
Why do we still care about them?
Because many aircraft built from the 40s to the 60s were certificated under them. You might need to reference them for older aircraft or minor changes.
Example.
CR3, Airplane Airworthiness Normal, Utility Acrobatic Restricted, was the basis for today's Part 23. Covered flight, structure, design, power plant equipment. Think Piper PA series, Cessna 182, 195, 300. Many were CR3 aircraft.
And watch out, CR can also mean Canadian Aviation Regulations.
Good point, yes.
Yeah.
Context matters. There's also CR4A from 1936, basis for many 30s, 50s planes. Later CR3 focused on small planes, CR4AB on larger ones.
So the key is always check the TCDS.
Always. The type certificate data sheet tells you the specific certification basis. A Cessna 140 might be CR3 as a land plane, CR4A on skis. A Gulfstream G2 might be CR4B, but the GRA variant, Part 25, it varies.
Okay, historical context is useful. Now, it's a serious issue. Suspected unapproved parts.
It's very serious. Our source breaks parts into 4 categories.
Good parts, good paperwork. Good parts, bad paperwork. Bad parts, good paperwork. And bad parts, bad paperwork.
Exactly. Only Category 1 is acceptable.
Categories 2 and 3 are SUPs.
Right. Good parts with bad paperwork, or bad parts possibly masked by fake paperwork. Technicians need to be vigilant.
What if you suspect a part?
Immediately tell your supervisor or quality control. Segregate and quarantine the part until its status is confirmed. Contacting the manufacturer is often a good first step. AC 2129 has more guidance.
Okay, vigilance is key. Let's wrap up with some other FAA documents technicians should know about.
Sure. First, advisory circulars. ACs.
Guidance, not regulation.
Mostly, yes. They provide FAA guidance, explanations, best practices, not regulatory unless specifically incorporated into a rule. Their numbering usually relates to the FAR part they discuss. Revisions get a letter suffix, like AC 43.13 up 1B.
Okay. Airworthiness directives, ADs. We covered these, but maybe a quick recap.
Legally mandatory rules under Part 39, issued for unsafe conditions likely existing in other products of the same design, require corrective action.
Issued how? NPRM, then final rule. Emergency ADs.
All of those. Emergency ADs require immediate action upon notice. ADs describe the issue, affected products, required action, compliance time. Numbering is year by weekly period sequential. Compliance is mandatory per 91.403. You can request FAA approval for an alternative method of compliance, AMOC.
What about Special Airworthiness Information Bulletins, SAIBs?
These are informational alerts, education, recommendations, non-regulatory, used when something doesn't meet the criteria for an AD but warrants attention.
Like the Cessna seatbelt bracket example, recommendation, not mandate.
Exactly. SAIB CE 1513 referenced a Cessna service bulletin recommending steel brackets instead of aluminum, but it wasn't an AD at the time.
Okay. Aircraft specifications.
Yeah.
Older documents.
Yes, FAA record-keeping docs for type certificated and some non-TC products, dating back to the Air Commerce Act. No longer issued, but still in effect amended. Can be converted to a TCDS by the TC holder. Not part of the TC itself. 5 historical groups based on certification basis.
Supplemental type certificates, STCs.
Yep.
Approvals for modifications.
Right. FAA approval for a major change to an existing TC'd product, aircraft, engine prop. It defines the change, its effect, serial number applicability, and certification basis. The STC and its data belong to the STC holder. You need their permission to use it. They have a specific numbering system, too.
And type certificate data sheets, TCDS, the official description.
Exactly. Formal description listing limitations and info for type certification, speeds, weights, thrust, etc. Part of the TC itself, per 21.41. Evidence of type certification. Compiled from TC holder data, FAA can add details. No operation without an airworthiness certificate, which requires meeting the TCDS specs. Categorized by holder product type, revised as needed, like the Beach King Air TCDS A24CE example.
Don't forget FAA handbooks and manuals.
Right. Huge resource for beginners to pros. Cover countless topics, updated periodically. List available on the FAA website.
What about non-FAA documents?
Important ones exist. The Air Transport Association, ATA iSpec 2200 is a big one.
The standard for organizing tech data on large aircraft.
Yes, uses sequential ATA chapter numbers for consistency across manufacturers. Makes finding maintenance info much easier.
And of course, manufacturers publish data.
The absolute primary source. OEM data is king. Part 21.50 requires ICAs, instructions for continued airworthiness, be provided with new products, STCs.
And those ICAs have to be comprehensive.
Extremely. English manual with descriptions, operating info, servicing, maintenance instructions, schedules, tolerances, overhaul periods, inspection programs, troubleshooting, removal replacement, testing, diagrams, special techniques, fasteners, special tools, everything.
Plus that mandatory airworthiness limitation section.
Critically important. Mandatory replacement time, structural inspections. Technicians must have current, correct data and tools or risk violating regs like 43.13A and 43.16.
What kind of manuals do manufacturers provide?
Airplane flight manual, AFM, serial specific, or pilot's operating handbook, POH model specific, often the same thing now, required on board. Maintenance manuals, AMM for whole aircraft, CMM for components. Service bulletins, SBs, usually advisory unless tied to an AD or inspection program. Structural repair manuals, SRM for structure repairs, often separate for large aircraft.
Okay, that covers data. Lastly, forms.
Key ones. Airworthiness certificates. Shows the plane meets its design and is safe, separate from registration ownership. AC 2112 guides the application, Form 8130-26.
2 types, standard and special.
Right. Standard, Form 8100-2 for normal, utility, transport, etc. Special, Form 8130-7 for experimental, light sport, restricted, etc., issued by FAA designees, must be on board and displayed at entrance, can be revoked if aircraft ceases to be airworthy.
The aircraft registration. Form 8050-1 application leads to AC Form 8053 certificate. Required for U.S. owners. Pink application copy or certificate must be on board.
Correct. Radio station license generally not required anymore for domestic U.S. flights since '96. Was an FCC requirement for international.
And FAA Form 337, Major Repair and Alteration. We discussed this under Part 43, Appendix B. Documents major work, needs approved data reference, IA or repair station signs off, copies to owner and FAA. Repair stations can use work order for major repairs, third copy on board for ferry tanks.
Exactly. A crucial form.
Which brings us neatly back to records.
Making those maintenance record entries per 43.9 and 43.11 is non-negotiable. Retention rules are in 91.417. Good logs are vital for aircraft value.
We have temporary records, 91.417 ABO1 kept 1 year or until repeated superseded. Maintenance, alterations, inspections. Need description, date, signature, cert info.
And permanent records, 91.417A to be due, kept by owner, transfer with aircraft. Total times, life limited status, time since overhaul, inspection status, AD status, Form 337s for major alterations.
And the shift to electronic records.
Big change. Started with simple programs, now sophisticated commercial options that help with research, ADs, SBs, and recording, log entries, tracking. Can boost efficiency.
Things to consider when choosing a system.
Aircraft size capability, templates, forms access, weight balance, search function, internet needs, capacity.
Wow, okay. That was a very comprehensive tour.
It's a lot, isn't it? As you can tell from our discussion, the world of aviation regulations is, well, vast and deeply interconnected. Getting a solid handle on these rules, the forms, and the absolute necessity of good records is just fundamental for keeping aircraft airworthy.
Yeah, and the key takeaway really seems to be that airworthiness isn't just a one-off thing at the factory gate. It's this continuous responsibility shared by owners, operators, and the maintenance crews, all guided by this whole framework of regulations and records.
Absolutely. This deep dive gave a foundational overview, but honestly, each specific area, ADs, STCs, record keeping, Part 145 repair stations, warrants its own deep exploration, depending on what you do in aviation.
Definitely food for thought. So here's the final thought for our listeners. Considering how complex aircraft are getting and how the regulatory environment is always evolving, what do you see as the biggest challenges ahead for ensuring continued airworthiness in the future?
That's a big question.
It is. Something to reflect on. Maybe dig deeper into some of the regs or topics that caught your interest today.